Section 6.2, page 326, try it yourself 1. We're trying to find the critical values now. And so the critical value is the T sub C for a 90% confidence interval when the sample is 22. So all we need to do here is find our degree of freedom. Because if you look at your table here, you need the degree of freedom. Degree of freedom is going to be n minus 1. And since our sample size they've given us is 22, we're going to do 22 minus 1, which gives us 21. And it's a 90% confidence. And so our T sub C is going to be what we get when we look up the degree of freedom is 21 and 90% confidence. So let's go back to our table, table 5. We've got the degree of freedom is 21 and we've got a confidence interval of 90. So we're going to go to 90 and 21, and that'll give us 1.721. And so that's how you find your T sub C with the small samples. This is for the small samples. Section 6.2, page 328, try it yourself too. You randomly select 16 coffee shops and measure the temperature of the coffee sold at each. The sample mean temperature is 162 degrees Fahrenheit with a sample standard deviation of 10 degrees Fahrenheit. Find the 90% and 99% confidence intervals for the mean temperature. Assume the temperatures are approximately normally distributed. So let's start with what we're given here. And so we're given our N is 16 coffee shops. Our X bar is 162 degrees. And our S is our standard deviation here, sample, so it's a small s, is 10 degrees. So the only difference between part A, which is going to be the 90% confidence interval, and part B, which is the 99% confidence interval, is going to be the T sub C. So we need to find a T sub C for each of these. So the T sub C for the 90% and for the 99%. And so before we can find our T sub C, we need two things. So we need our confidence, which is 90 and 99, and we need a degree of freedom. The degree of freedom for both of these is going to be n minus 1. In this case, our n is 16. So it's going to be 16 minus 1, or 15. So let's go find our T sub C's for these. So we're going to use table 5, our 90% at 15. So we got 15 for our degree of freedom. 90% is going to give us 1.753. And for 99%, we're going to get, and our degree of freedom is still 15, 2.947. And so now we're just going to plug all these numbers into our formula here. So for part A, we have 162 minus 1.753 times the standard deviation of 10 divided by the square root of 16. Make sure you don't use your degree of freedom here. Less than mu is less than the same thing but with a plus. So 162 plus 1.753 times the 10 over the square root of 16. So let's go to our calculator because we can just put this in one time and then change the minus to a plus. So we're going to do 162 minus 1.753 times 10 divided by the square root, which is second x squared, 16. And so that's going to give us 157.6175. Let's round it off 2 decimal places to 157.62. Is less than mu is less than. Now all we really need to do is go back here and change our minus to a plus. So you're going to hit second, enter, arrow back to that minus, and just change it to a plus. And press enter. And that's going to be 166.3825, so we'll round that up to 166.38. And these are both degrees Fahrenheit. Now let's take a look at part B. It's very similar. We've got the 162 minus, but then the 1.753 is going to change to 2.947 times the 10 divided by the square root of 16, less than mu, less than 162 plus the 2.947 times 10 divided by the square root of 16. When we go back to our calculator here, we need to change just a couple of things. So we're going to change this 1.753 and change that plus back to a minus for now. So we have minus, and then it's going to be 2.947. There we go. Press enter and you should end up with 154.6325. We'll go 2 decimal places again, 154.63. Degrees Fahrenheit is less than mu is less than, and then we'll go back here and we're just going to go back, second enter, and change that minus back to a plus. And that'll give us 169.3675, which rounds up correctly to 169.37. And so our two confidence intervals here for the 90% and the 99% for the temperature of the coffee.